Welcome aboard. I thought we'd test some water today here on the Tommy Technetium channel. Look at all these brands of water I've got. What do I got here? Some Abso Pure natural spring water. So it's probably got some dissolved minerals in it. Looks like we've got some Ice Mountain. Also natural spring water, so that's also going to have some dissolved minerals in it. We got some Evian water made by the French Alps. What's going on, Charlie? We're going to test some waters today. See what their pH values are. This one says it's 7.2 right there. Essentia water, that says it's pH 9.5. You can see that right there. Yep, pH quality guaranteed 9.5 or higher. What's going on, Detonator? Of course, I remember you. Today, we're gonna test some different brands of water, just for their pH. And then we'll do some experiments with them. Here's some Aquafina water. You'll notice here it says it's purified by reverse osmosis. So this is gonna be pure water, but not quite, as we'll see. And then we got some Fiji water. All right. So let's go ahead. Here's our yeah, absolutely. I remember y'all. So here is our pH meter. Not our meter, but our guide. Hey, Kim Jong, what's going on? And we're going to see what the pH of these various brands of water are, okay? What do you think? Which one do you want to do first? You want to do the Fiji? You want to do the Essentia? Let me know in the chat. What are we going to test first? I got what do I got? 1, 2, I got 6 brands of water here. Evian, Essentia, Aquafina, Ice Mountain, Fiji, and Abso Pure. Which one y'all want to test first? Fiji, you got it. Okay, so let's see. I saw Fiji first, and then we're going to do Essentia. So Fiji's on the docket first, then we're doing Essentia. All right? Then whatever's next. All right, so here we go with Fiji first. Let's look a little bit. What does it say about it? Anything I can learn about this by reading? It's a little tough to see. Let me turn this light on here for me. Oh, yeah, it's got some, you can see there's some additives here. Let's see. Let me just read here real quick. It's hard for me. We got some silica. We got some calcium. We got some magnesium. It also says on the label, on the pH, it's really hard for you to see. It also says on the label that it should be pH 7.7. So according to this bottle, we should be, you know, somewhere in the green region. Let's give it a shot. Here we go, baby. Let's add a little bit of universal indicator to our Fiji. Here's my universal indicator. I'm going to pull it out of this bottle so you can see what the color is. It starts off like a greenish color, indicating that it's neutral. So we're not adding acid or base. So let's go ahead and add it to the Fiji water. We're going to give that a nice little mix and see what happens, all right? Mix that up. Sure enough, yeah, it's got a nice green color to it. That's going to indicate we're at, you know, a pH 7 or higher. And that's consistent with what they say is on the bottle. Interesting. All right, so there's Fiji. Test number 1. Let's move on to the Essentia water, which folks said they wanted to see next. So we're going to do Essentia next. It says it's pH 9.5 or higher. So I am definitely going to be expecting to see like a, you know, a blue or a violet color, right? That's what I'd expect to see. They say this is alkaline water. Well, we can test that. We can also test the claim that it alkalizes your body, which sometimes people will claim. I got a viral video going out on that right now about whether this stuff can actually alkalize your body. Spoiler, it can't. Anyway, let's go ahead and add a little bit of universal indicator to our Essentia water. Let's see, baby. Come on now. In it goes. Oh, I'm seeing some blue and some violet. So that claim is fine, right? The claim that the pH of this water is like a 9 or 9.5. I buy that, certainly, with the you know, the universal indicator that I've added. It's kind of nice. We got like a violet color in one of the waters, and the Fiji is, you know, pH 7. So, you know, both these without the indicator, both of these are certainly fine to drink. But, you know, some people say they can tell a difference in the taste between different brands of water. And, you know, if the pH is that different, of course, there's going to have different additives, and that's going to taste a little different. Hey, thanks there, Iskra. Appreciate the shout out. Hello. Welcome aboard. So let's, hello there, Nuera. I apologize, I can't read that language. I'm so sorry. I'm embarrassed to say I can only read and speak English. But yeah, we've just tested 2 waters, and the first one came out like a pH of 7, which is consistent with the label. The second one came out like a pH of 10, 9 or 10, which is consistent with the label again. So let's try Evian. You'll notice that this one says its pH is going to be 7.2. Fiji says it's 7.7. So while this will probably come out a green color, it should be a little more yellow than this one. Agreed, Charlie. Different tap waters are going to taste different. So the reason why I'm going to say this may have a little different yellower shade is because this Evian water says it's pH 7.2. This one says it's pH 7.7. This pH is a little higher, this is a little lower, so it should look a little lower on the pH scale. It's going to have a little more yellow color to it, is my guess. But I don't know. Let's give it a test. So open up the fresh Evian water. And while I'm doing this, feel free to drop in the chat which brand of water you tend to like best, the taste of it. I'm going to pull up the universal indicator into this syringe, which you can tell is, you know, a nice green color. We're going to go ahead and add it. I guessed it's going to have a slightly more yellow color to it than the Fiji. Right now, I don't know if that's the case. Maybe I'm wrong. Maybe I'm feeding you a line of crap, which is kind of nice in science, that you can do tests and you can see if somebody's giving you a line of bull or not. What do you think, folks? What do you think? Let me get this out from behind so we can kind of compare. That actually looks a little more blue to me. It really does. But it could be that, you know, it's a little more dilute as well. But those 2 shades of green look roughly the same to me. Let me go ahead and try to add a bit more indicator dye to the Evian water, just to make sure that we have sort of the same concentration of the dye. Now, I know I'm eyeballing it, so you're going to have to forgive me. This isn't a precise test. But nevertheless, we can get some insight here. I'm going to add maybe, that's about a 50% more. So I'm going to try to add a half a squirt here to just try to get the same concentration of dye, indicator dye, in the Evian water. Or Evian, I'm sorry, I say it wrong. So Charlie doesn't like water at all. Okay. Evian low-key tastes like Dasani. But yeah, to me, those kind of look like those look the same. Let me just reverse these to make sure it's not like a, you know, a lighting effect. Those look like the same shade of green to me. Now, this one says it's pH 7.7. That's what Fiji says on the bottle. This one says 7.2. It could also just be that the indicator dye that I'm using can't distinguish between pH values that are that slight. Could be. But anyway, to recap, Essentia certainly has a pH 9.5, and these 2 bottles of water are certainly near pH 7. We got some other ones to test, though. I always like testing Aquafina because it has indeed been purified. So this is kind of interesting. I want you to recognize that this water has been purified by reverse osmosis. So compared to all the other brands of water that I've been testing, this one happens to be the most pure. Now, people don't like it when I say that. I'm just dealing with, you know, the quality control specs that you can find online for these things. This has indeed been purified by reverse osmosis, okay? It's been purified by reverse osmosis, and I've done tests on this to show that indeed there is very little solid dissolved in this. So this is very close to pure. So, you know, we expect pure water to be pH 7 because water is neutral. So, you know, naively, we would expect, a lot of people like to point out that Evian in reverse is naive, but nevertheless, naively, we would expect that this purified water would be pH 7 and turn green. Let's actually see what happens and then talk about it. From what you heard, water tastes mostly about how clean your mouth is. That's pretty funny. All right, here we go. Here's the Aquafina water. Let's give this a squirt here. So make sure to brush your teeth or maybe eat some mint leaves prior to drinking. Here we go. Let's add some to the Aquafina water. And it looks green going in, but look at that, man. Look at that change. And I am not surprised by this, although some of you may be. Ask a question. Okay, let's try something. What color did you think? I'm adding a sticker here. The Aquafina I spelled it wrong. Sorry. Bear with me. YouTube is having me test something out. So you guys are going to get to see a new feature here on live. The Aquafina would be. There we go. What color did you think the Aquafina would be? And let's go ahead and pop it on there. Start the Q&A, baby. What color did you think the Aquafina would be? So look at that. It's like a yellowish or an orange. Yep, a lot of people are saying they expected that, orange and yellow, sure enough. And that tells us that, oddly enough, this purified water is going to be like a pH 5 or 6. Isn't that interesting? So even though it's been purified, it has a pH of like 5 or 6. Now, why might that be? What might that be? Well, that's because any water that's exposed to the atmosphere is going to have carbon dioxide from the atmosphere dissolve in it. And guess what? Carbon dioxide's acidic. So because this is pure, and I guess it's not completely pure, right? Because some of the CO2 from the atmosphere gets in it, but pure water that has CO2 in it, it's just going to, there's nothing to react with the CO2, so the CO2 stays acidic, and that's why purified water is going to be orange, slightly acidic, very slightly acidic. All right, I'm going to pop this off to end the Q&A. That was kind of fun. These bottles of water, on the other hand, have additives added to them, and so even though both of these have some carbon dioxide dissolved in it, the additives that are present can raise the pH a little bit, and that's why these two waters are a little bit higher. And then, of course, if you add the right additives, you can get that pH kind of high, and then you can call it alkaline water. That'd be cool, man. I'd like to test Poland spring water. By the way, what is osmosis? Charlie, what osmosis is it's where you set up a membrane through which water can pass, but ions cannot. And what will happen is if you set up water on two sides of such a membrane, two solutions, the water will pass from the purified water portion through the membrane into the portion of water that contains salt ions. Semi-permeable membrane detonator. The biologist has entered the chat. So here we go. We're going to test some ice mountain water. We're also going, what's the best water to buy, Mike? Pretty much any water. Just don't get water from a hot garden hose or, water that's been stored in the car in a very, very hot bottle that's been stored in a very hot car. So both of these are going to have some additives because, it's spring water. And as water travels through groundwater, it picks up dissolved solids as it flows through. And some of those solids get into the water. And people tend to like the taste of minerals when they're dissolved in water. Like really pure water, most people don't like the taste of. It kind of has like a sharp taste if you're really paying attention. And that's because, indeed, it's going to be slightly acidic remember, it's just from the dissolved CO2, which all of these waters have dissolved CO2 in it because they're all exposed to the atmosphere. Anyway, let's try the ice mountain water. I have no idea what this pH is going to be. I've never tested it before. My hunch is it's going to be like a pH 7 green color, but I don't know. Let's find out. Yeah, drop your go-to water in the chat. Looks like Nathan goes for spring water. Here we go. Let's add a little bit of our universal indicator to the ice mountain. And as I expected, I am seeing a slight green color. That's because there's going to be some additives in the spring water as the spring water moves through the ground. And so we're not going to have pure water. Again, pure water with carbon dioxide is going to be yellow. Hello there, Amelia. Hello there, Shujat. Okay. It is slightly blue. I agree. It's got a slight blueness to it. So I think this one might be a little higher than pH 7. So there's that one. And I'm guessing that our Abso-Pure natural spring water, I'm guessing that's also going to have like a slight green color to it. Let's find out. Spring water over purified. Yep. Okay, here we go. Last one we're going to test is the Abso-Pure. And then what I'm going to do is I'm going to show you how carbon dioxide can acidify all of these different types of water. That'll be our next test that we're going to do. So here we go. We're going to add our universal indicator. You can see the pH scale right here in the back. All right, I'll put that off to the side so you can see what the pH of our Abso-Pure water is. It's going to be funny that they call this Abso-Pure because it's not going to be pure because it is natural spring water, which means, as you know, spring water as it moves through the ground, it's going to pick up some dissolved minerals. So I would not expect this to turn yellow. I don't know, Shujat. I have no idea. So you can see here, I've got my universal indicator. You can see that it's green in color. It starts off neutral. We're going to go ahead and add that to the Abso-Pure, and sure enough, that's going to be like a pH 7, maybe a little bit greater than pH 7. And we're going to remember that water that is, you know, going to be slightly alkaline or neutral must have some dissolved solids in it. It's got to have some dissolved solids in it. Otherwise, the carbon dioxide would make it acidic, like this pure Aquafina is. All right, now, I've been jabbering on about the impact of carbon dioxide. Let's actually watch this. So it's a real easy test. It's kind of fun to do. Give me a second here. I got to get a straw. Where's my straws? Here they are. Okay, here's the test. I'm going to take, let's take this bottle here, right? This Abso-Pure. And I'm going to pour a little bit out so that I can exhale through this straw into the bottle of Abso-Pure. I wonder how much minerals are present detectable in spring water. Clearly enough to affect pH. That's true there, Cooler. Definitely. Oh, CJ, I should have tried tap water. Unfortunately, I don't have any downstairs. I mean, if you want, I can, you know, if you all give me some thumbs up, I can quick run upstairs and go get a sample of my tap water. I just, you know, I need to see 10 thumbs up if you want me to do that. While I'm doing that, I'm going to go ahead and dump some of this out so I can do the carbon dioxide test. So if I see, there's 1, 2. I see 2 thumbs ups. So I know 2 people. There's 3, 4, 5. Obtorge gave me a wave. Paige, Extreme, CJ, Addie, Charlie. Okay, we're going to be going. Joshua, Nathan, Satchel. Thank you, everybody. Whitney, Charlie, Perel, Orbtaj, Joshua, Tapu, Safaran, Joshua, Detonator, Shujat. Okay, I see you all. It's going to take a little bit of time, but you'll notice here I'm going to go get some tap water. All right, so I'm going to first do the Abso-Pure test. So what I'm doing now is to show you that carbon dioxide, when it dissolves into water, it acidifies the water. So here's the way we're going to do this test. If I exhale into water, can the gases in... There you go, baby. John Doe, you got exactly what I'm doing. John Doe says, if you exhale into water, can the gases in your breath dissolve into the water you exhale into? Absolutely, John Doe, and that's what I'm going to do. So obviously, I exhale carbon dioxide, about 4% of what... Rip off the label. Thank you there, Charlie. Thank you for the... Appreciate that. Uh-oh. I might not have the tools to get that done. But yeah, I'm going to exhale my breath into this bottle. And you should recognize that 4% of what I exhale is carbon dioxide. It's not 100%. Thank you, Charlie, for the suggestion. Here we go. Here's the pH scale. I'm going to exhale about 4% CO2 into this, and you're going to watch what happens. And, you know, you might want to time about how long it takes, because the longer it takes for me to turn this to like a yellow or an orange color, the more additives there are in here, okay? Got that? And then, you know, you're going to have to all keep track of that. So I'm going to do Abso-Pure first. Let's do the countdown. 3, 2, 1, start. So get your timers ready. Here we go. 3, 2, 1. Holy cow, that's taking forever. I'm done. I'm not sure that's going to go, but you can certainly tell that it's certainly less basic than it was before. So I stopped after 44 seconds and this still has a way to go, okay? And it's not yellow yet. It's definitely not yellow yet. So keep that in mind for our Abso Pure, okay? Now the next one, well, we're not going to do Aquafina because that one, that one's 0 seconds, right? This one's pure. It has got the CO2 in it. We can tell it's already acidic. So that one's 0 seconds. Abso Pure is 44 and it's still got a way to go. Let's do Essentia next, okay? Essentia is at pH 9.5. They call this alkaline water. Let's see how long it takes for my breath to acidify the Essentia water. Okay, here we go, folks. Are you ready? Where's the tap? I'm going to do it, Tapu. I promise. I'm going to do the tap after let's test all these first. I think the flow is kind of working this way. I am going to do tap water, okay? Okay, here we go. Get ready to time me, folks. Let's see how long it takes this. And I'm going to try to get this to go yellow, okay? If not, I'll stop when it hits here. We'll see how long I have to blow. We'll blow at least 44 seconds like we did last time. Okay, let me get my breath here. All right. Here we go. Get your timers ready. On your mark. Get set. That's yellow, folks. That's yellow. How long did that take? Huh? How long did that take? 16 seconds. Why I'm laughing, folks, the reason why I'm laughing is because you're going to have to forgive me, but people sell this alkaline water. I buy it because it tastes good to me. So I like Essentia water. I like the taste of it. But some people claim that it alkalizes your body. Well, come on, man. We just found that 16 seconds worth of the carbon dioxide that I produce acidifies this stuff. So if you're buying this stuff to alkalize your body, first of all, you're misinformed, and we can talk about that if you wish. Second of all, this ain't going to work to alkalize your body because in 16 seconds, you're going to produce enough carbon dioxide to completely acidify this stuff. This is totally a marketing gimmick. So we can see that this bottle, the Absopure, has a lot more additives in it that allows it to keep the mixture neutral, whereas this just has a sniff of stuff in it that indeed makes the pH basic, but there's not enough in it. There's just a tiny amount of base. It happens to be a strong one, but it's a tiny amount so that my CO2 from my exhaled breath just acidifies it in 16 seconds. Come on, man. So everything you open, there is a chance of adding acidity. Saffron, any bottle that's exposed or sealed under atmospheric, air is going to have carbon dioxide dissolved in it, and the carbon dioxide makes the water less basic, more acidic than it otherwise would be. Now, pure water like Aquafina, that's going to be acidic because it's just carbon dioxide and water, and that's acidic. However, if there are additives in the water, that can change the pH. That's, you see that in the Fiji, which has additives. You see that in the Ice Mountain, which has additives. You see it in the Evian that has additives, okay? So if it's pure water with nothing else in it, well, I can't say nothing else because there's some CO2 in it. It's going to be acidic to begin with. You have a bottle of alkaline water right next to you. I love the taste of it, Funnel. I hope you do too. Will Aquafina turn red? Great question, CJ. Let's do it. It's not going to because this already has the maximum amount of carbon dioxide in it that can dissolve. But I'll show you. We'll go ahead and show you, okay? What does the alka thingy mean, Carly? It means the opposite of acidic. So alkaline means basic. We, here in the United States, use alkaline and basic synonymously. And alkaline and basic mean the same thing. JCD, it doesn't really matter. Just don't drink water from a hot hose. I think you're going to be good. Okay, I'm not here selling any water, man. I mean, it's all good. It's good for hydration. It's just water, man. It's just water. Look at your local tap water registry. They'll tell you what's in the water. As long as it doesn't have any bad stuff in it, go for it, man. It's good stuff. All right, here we go. So yeah, the best water to drink is whatever's available as long as it doesn't have any toxins in it. And none of this does, right? No, I mean, okay. Let me talk about that just for a second. So we chemists are really dang good at being able to detect stuff. So yes, I can find stuff in this Aquafina that's probably not good for you, but that's because we chemists are extremely good at finding stuff nowadays. Like I could analyze someone's hair in the chat, and I could find levels of lead in your hair. But here's the deal, folks. When chemists find something like a toxin in something, there's two questions you need to ask. How much did they find, and how much does it take to hurt you? The amount of toxins in all of these that I could find are not going to be anywhere near what's going to take to hurt you, okay? So you're going to be fine, man. Don't worry about the water you're drinking. You know, as long as you've got the safety spec on it, you read it through and there's nothing wrong. Okay, folks wanted to see me exhale into this to see if this goes more acidic. I'm going to give this about 20 seconds, okay? Here we go. 1, 2, 3. You know what? You know what? You guys made a liar out of me. You all made a liar out of me. That's more orange than it was before, man. I love it. Man, I love it when that happens. Gosh, I love it. So somebody in the chat said, hey, why don't you exhale into this and see what happens? I'm like, man, nothing's going to happen. And I am so wrong. Love it when that happens. Because when I learn where I'm wrong, then I learn something new. And I don't have to be wrong anymore. And I love it because now I know that if I try that, I can actually get a little more CO2 in there. We can actually see the color change and see that indeed the CO2 makes this even more acidic. Isn't that cool, man? Come on, buddy. Who was the one who said I should do this? Whoever that is, I owe you, man. Or woman, or whatever the case may be. Quantity makes the poison. Come on, Charlie. Thank you there, CJ. That's right. It was you, CJ. CJ wins the chat right now. I don't have any liquid death spring water, but blue haze, I'll try to remember to do it, okay? CJ, that's awesome. Thank you, CJ. I'm so wrong. And you know what? You know what I love about science? I tell my students this all the time. What I love about science is that it's often in a science class where you will tell your professor that they're wrong. They'll think about it and they'll agree with you right there on the spot. Because what's beautiful about science is if we all put our heads together and we apply the mathematical and scientific and logical principles looking at what we're observing, we all see the same thing. It's all the same math. It's all the same logic. So we come to the same conclusion. And that's really a beautiful thing in my classes, because my classes, we come from a wide variety of backgrounds: religious, political, cultural, all sorts of different backgrounds. And when we go through stuff, we come to the same answer. So it's a really cool thing. Anyway, let's do Ice Mountain next. Protein powder testing, unless it's quantum stuff. I don't know about that. All right. Here we go. Now, something we got to keep in mind is these tests aren't really quantitative, because we should recognize, there's not nearly as much material in the Ice Mountain water than the others. So we're not doing a fair test, because we're not testing the same volume of fluid in each case. But still, we're getting some insight. We are getting some insight. So here we go. Let me see if I can't get this label off. Yeah, come on, man. Give some love to CJ in the chat. CJ corrected the PhD chemist here, which I love. Love it. I love being wrong, man. Because when I'm wrong, and I admit it, I don't have to be wrong anymore, at least about that instance. There's all sorts of other things I get to be wrong about still. Trying to find out where you're wrong. That's science, baby. Okay, here we go. We're going to do this was the Ice Mountain water, right? Here we go. This will probably slowly go back to the color it was before, but, CJ may have something to say about that. Okay, here we go. This one's the, what's this, Ice Mountain, right? Yeah, this one's Ice Mountain. Let's see how long this takes. Here we go. I'm either going to blow for 45 seconds or until it turns yellow. All right, here we go. On your mark, get set, go. I'm gonna call that yellow. It's not as yellow. Was that 45 seconds? Roughly? Whew. How long was that? Man, I'm getting lightheaded here. Okay, roughly. So we can, look at this. We can tell that this had very little additives in it because I was able to get that yellow in, what was it, like 15 seconds. Comparing these two, you know, I blew into both of these for about 45 seconds each. And this one is a little more yellow than this one. And so it's almost the same volume too, really close, because this has got a wider base. So I would say this probably has more additives than this. Okay? Next one to test is going to be the Fiji. Fiji water's next on the list. Here we go. Let me pour some of this out. Thank you there, Shane. Nathan Gibson. I don't know the question, man. Oh, man. The chat keeping me honest. Here we go. We got Fiji now. I'm going to blow into this. So what's the best bottled water to drink? Alora, whichever one's around when you're thirsty. I'm serious. It really doesn't matter. It's all good for hydration. All good for hydration. It depends on what your tastes are. Most people find this stuff, Aquafina, to have like a sharp taste to it. Most people do not like the taste of purified water. I can, and here's why. Here's why. Bases, like on your fingers, they tend to be slippery. And I think that also translates to your tongue. So bases tend to feel slippery. And so that in your mouth, that's going to feel smooth. And so, you know, the more basic it's going to be, the smoother it's going to sort of feel in the mouth. And the more acidic it is, the less slippery it's going to feel, and that's going to have a sharper taste. That's my guess. That's my guess. Okay, here we go. Get ready to time me. I'm going to now exhale 4% carbon dioxide into the Fiji water. I don't care. We can show that. Okay. All right, here we go. Here we go. We're going to go ahead and exhale into this. Get ready to time. Oh, come on, Charlie. Doing science on a summer break. Here we go. Okay. And 3, 2, 1. That's close to yellow. That's close to yellow. It's not as yellow as the other, but it's getting close. How long did I go? How long? Yeah, that actually looks yellow to me. It's got just a tint of green. 31 seconds. Okay. So if we kind of, you know, organize these in terms of which has the most additives, I would say first was our Abso Pure. Second was our Ice Mountain. Third would be Fiji. Fourth would be Essentia, and of course, bringing up the real is Aquafina because that, you know, had nothing in it, so it was acidic to begin with. One more to go. Thanks, RX Clips. Thanks, RX Clips. Glad to have you on board. Just doing some water tests. And the last one we're going to do, of course, is my tap water, but you're all going to have to give me a chance to go upstairs. I'm going to have to rinse out the bottle really well so that there's no crap in there, just the tap water, okay? All right, here we go. I'm just dumping out a little bit of the Evian water. Sorry, it's Evian. I say Evian. I made a video about it and said Evian, and man, people lost their minds on that mispronunciation. Yeah, and then the tap water, CJ. So here's my Evian water, and I'm going to exhale into this. We're going to see what happens, okay? Let me get my breath here. I don't want to pass out on everybody. In it goes. Oh, no. It's down in there. Let me get another straw. I'm just going to get it dropped in there. All right. Okay. In 3, 2, 1. All right, I'm guessing that's about 40 seconds. I could be off. Let me know what you all think in the chat if that's roughly 44 seconds. Yes, that's right, SMH. It's the different amount of minerals in there that give it a different acidity. So 39, I could have went a little longer, but it looks to me like this has still got a bit more green in it than all the rest. Here, I'll show you what I'm seeing. This is what I'm seeing in my eye. This has like a darker forest green color. This one's got a little bit more yellow tint to it. Why does CO2 make water acidic? Let me show you here, okay? I'll give you the chemical equation. But here's what we got in terms of our rank. This one's going to have the most additives just based on this simple experiment we did. And then it goes, so it goes Evian, Absol-Pure, Ice Mountain, Fiji, Essentia, and then Aquafina. And what's funny is the Essentia, which is sold as alkaline water, has a tiniest amount of stuff in it. So, you know, anyway, here, let me show you the equation, the chemical equation that shows how CO2 makes water acidic. I'm just going to write it right here. So it's carbon dioxide, CO2, plus water, H2O. And what you're going to get is something that we chemists call a proton. It's an H plus ion and the bicarbonate ion. So here's the chemical equation that describes the acidity of carbon dioxide. When carbon dioxide reacts with water, it releases this thing that we call a proton. And this is the active thing in acid. So this H plus ion is what makes acids acid. So anything that releases this is going to be an acid. So when CO2 gets into water, it promotes the release of a proton, and that's why we call it an acid. And then, you know, to balance everything, you make the bicarbonate ion. And indeed, this is the counter ion to sodium in sodium bicarbonate, and that's baking soda. So you're making basically acidic bicarbonate is what you're doing. So there you go. If you had to grab some water fast at a convenience store, sorry, I don't understand the question. Yeehaw, H+, come on, Schwarzer. Chemist has entered the chat. Who's breathing air in their water? Well, the atmosphere is always, in a sense, breathing air into our water. And so the atmosphere does contain CO2. And so when that CO2 goes into your water, it's going to make it more acidic. Which one's the best one to buy? Krista, whichever one you like the taste of. All of these are fine to drink. I'm not selling any of them. I'm just, bottled water and people arguing over which one. It's mostly about taste, to be honest with you. And some people do notice, for example, some people claim, and I buy this, people claim that essential water tends to help with acid reflux. Some people claim that. I believe that. Yeah, sure. But it's not going to alkalize your body, people. Like, you got a buffer system in your body that keeps your pH and the various regions of your body tightly regulated. Okay, now you guys are going to have to bear with me. I'll give you something to watch. Let's get something set up to watch while I go get some tap water, because we're going to test that next. But you guys don't want to be bored, so I'm going to get something set up for you while I'm doing that. So let's get this thing going. All right. You don't want to be watching nothing. We got to see some stuff. All right. And I'm going to add to this. You guys will like this. And then I'll go get the tap water and we can test that. Let's add a little bit of distilled water into this. I don't know if my flask is entirely clean. And if it's not, yeah, let's put this one on there. There we go. This will give you something to look at while I'm going to get some tap water to test. Let's pop this in here. Here's some distilled water, which is indeed purified. I'll just show you here. I'm a Midwesterner, so of course it's from Meyer. There's your distilled water. All right. We're going to pop a little bit of universal indicator in there. And if my flask has been cleaned, which I'm not sure it has been, but if my flask has been cleaned, remember, distilled water is purified water. And therefore, since this has CO2 in it, it should go a little bit yellow, right? We saw that before. And it's going yellow from the carbon dioxide that's dissolved in the water. And sure enough, that's what we see. It's exactly what we would expect to see, okay? Let's add a little bit. We got to get some color going on here, baby. Let's get some color. I think that's going to be enough. Color makes things beautiful. Look at that. It's gorgeous. Okay, now, just for fun, I'm going to add some acid to this. All right. So here's your pH. Don't forget your pH scale. Right? That's your pH scale. A little harder to see. I'm going to add some hydrochloric acid, the same acid's found in your stomach. Come on, man. Look at that change to red. Of course it changes to red. Hydrochloric acid is very acidic, right? So, you know, we're like pH 3 or below right now. Now I'm going to turn this off. I'm going to add some base, some sodium hydroxide base, which is alkali. I'm going to add a few drops of this, and you're just going to watch what happens, all right? While I go get some tap water to test, and then we'll come back and test that. Here we go. Let's add like, I don't know, 1, 2, 3, 4. There's 4 drops of that stuff. I don't know what's going to happen. You guys tell me. I'll be back. I'm going to go get some tap water, and just so you know, I'm going to pop it into this bottle of Evian, all right? I'm going to just add a little bit more acid here around the sides just to make it pretty. There you go. All right, folks, see you in a bit. Going to take me about a minute, maybe 2. Got my tap water. Here I come with my tap water. Let's see what it looks like. Kind of boring, huh? Let me see. Yeah, just kind of red on top, violet on the bottom. Let's go ahead and mix this up, see what happens, all right? Give that a mix. And if there's more base than acid, it'll turn violet. If there's more acid than base, it'll turn red. Looks like it's violet. Let's add a few drops of acid here just for the heck of it before we test my... Oh, you can still see the acid in the middle. I'm going to add a few drops there. It's gorgeous, isn't it? Come on, man. Look at that. Just love the colors. What's neat about this is, of course, the acid and the base neutralize each other. So, basically, you can think of it this way, that the red and the violet, they neutralize each other. They pull everything closer to 7, but they do it at, different speeds and different places. And so you get to see all the different colors between 3 and 10, which is really cool. I'm going to go ahead and make this acidic before we do the test on the tap water. We'll get back to the tap water in a second. Scroll up, chat. All right. Someone tell me to scroll up in the chat. Look what Roger did. Look what Roger did. I got to scroll up here. Come on, Roger. Come on, Roger, baby. Beside the taste, which one has the highest pH? Roger, the one with the highest pH would be the Essentia water. Thank you for the gift. You didn't need to give me the gift to try to answer that question, but I definitely appreciate it. Roger Liddell Jr., baby. Thank you so much. Appreciate everybody letting me know that he did that. Appreciate it. Okay, let's see if I can get this real quick. We're going to see all the different colors. I'm going to add, I don't know, 2 drops of base here. Let's just see. 2 drops. Give it in there, see what we got. Come on, baby. Come on, baby. Give me the rainbow. Oh, not that time. All right, let's try one more time. 5 drops of acid. Get it back acidic. Let's go 1 drop of base. Come on, Roger. We got to get the rainbow for Roger. Let's do one more. Come on, Rainbow Roger. I think the speed's too fast. Yep, the speed's too fast. We got the oh, that's not too bad. We got a little flash of it. A little flash. But I think if we do a little slower. I know, you guys don't want to see the tap water. Enough of this, huh? Oh, that's cool. Like a little tornado there in the middle. Thank you there, James. Appreciate it. That was cool. That was cool. Here we go. Come on now. This is it. Here we go. 2 drops. 2 drops. Let's do it. Look at that gorgeousness. Come on now. Give me the rainbow. I'm just off today. I am just off. I don't know. We got a little bit of that. There we go. There we go. We had a little flash of it. Love it. Little flash of the rainbow. Didn't last long, but it was there. Try her again. Look at that. Oh, man, look at those flow patterns. Gorgeous. I'm going to try one more. Come on, give me the... Come on, give it. No, I'm not drinking it. One of the dyes in there is a laxative. That would end the live in about 10 minutes. All right, let's test my tap water. Here we go. Enough of that stuff. Tap water test coming up. This is going to be it. This is going to be the last test. All right. And then I'll flip the camera on. You guys can see my ugly mug if you're into that kind of thing. All right. Just know that's coming. That is definitely coming. Okay, so here's my tap water. I know it's in a bottle of Evian. I told you that was what I was going to stick it in, okay? Thank you there, Charlie. Appreciate it there, Krista. So here's my tap water. I have no idea what this pH is. This is what I make my tea with every morning. Where's my squirter? Where's my squirter? Here it is. Nope. It's not clean enough. I don't know if that had acid in it or not. That would ruin the test. Here, let's just get a fresh one. All right, got a fresh squirter. In goes the universal indicator into the main event. Is coconut water better than pH water? Roger, I have no idea. I would say yeah, because it's going to have some more nutrients in it, but I don't know what you're going for by better, yeah. So anyway, we got some pH 7 universal indicator, and it goes. I'm going to do another squirt because there's a little bit more water in there. And it looks like my tap water is right around neutral. Sure looks like it to me. Yeah? It's got a nice little green color to it to begin with. All right, let's see. I'm going to get these out of the way so we can see the color a little better. Let's see how long it takes to neutralize this through, well, not neutralize it, to acidify it by breathing, 4% carbon dioxide into it. Aim of the experiment, toolbox. What we're doing is we just tested the pH of a bunch of different brands of water, and then I acidified them by exhaling into them through a straw. When I exhale, I'm exhaling 4% carbon dioxide like all of us do. So I exhale 4% carbon dioxide into this and it acidifies it, okay? Here's your pH scale. I'll put this up here while I'm getting everything ready so you can check that out. You know what the different colors mean. So right now you can tell this is neutral because it's green. I'm going to get my straw. This one I'm going to have to blow for a little longer because there's a lot more fluid, like a lot more fluid. So 45-second test is going to do it. We'll do about a minute this time, okay? We're going to go about a minute. Hello there, True Neutral. Here we go. Get ready. Get ready to time. On your mark. Oh, boy. Get set. Go. That went yellow kind of quick. So I would say my tap water doesn't have a whole lot of additives in it. I know it's still got a little green tint to it, but my goodness, there is a lot of water in there. I mean, what's this thing, like a half a liter? The other ones I was testing like 200 mils at most. So, yeah, so to recap, I think, you know, this started with the highest pH. Oh, man, actually, I don't know. One of these two was the worst with the amount of additives. If we're trying to keep things from being acidic, these two were kind of the worst. Of course, Aquafina is the worst because we know that has no additives. It's been purified, yeah? And so that one's going to be acidic to begin with. And the one that seemed to stave off for the longest was the Absopure. So there you go. I need to invest in a fish pump. Well, see, a fish pump is just going to blow air into it. And air is only what's like, 0.0004 percent roughly. Is that right? Or is it 0.04? It's 0.04% carbon dioxide. So when I exhale, I'm exhaling like 100 times more carbon dioxide in. All right, here we go. That's the end of the experiments. If you don't want to see an old man in their basement, it's time to get out of here now. Let me turn this off. I'll get a little lighting so I don't look so bad. How's that? Let's turn this around. Get a little lighting on my face. Because this is, you're going to see a 57-year-old dude. And, There we go. Turn this off. Flip this around. What's going on, folks? What is that? Hey, thanks, Safran. I appreciate that. Safran gave me a subscribe. I appreciate that. So half bread. Sorry, bud, you just joined. We're done with the experiments. I hate to tell you that. If I was to consume something basic, will the water turn blue if you blow into it? So, John, if I took something basic and I put it into the water, yeah, it would turn blue. I'm talking about the water now. So if I took something basic, put it into the water would indeed turn blue. And depending on how much I put in, if I put a bunch in, it would take me a long time to blow to acidify it, change the color. But if it was, if I didn't put much in, it would just take a little while. Thanks, Sarah. Hey, you like this? That's my periodic table shirt. I'd spend way too much time online looking for these. Appreciate that, James. Thanks there, Charlie. What's going on, CJ? Appreciate that, Zaheen. Thanks there, Krista. Appreciate it. Appreciate it a lot. Yeah, thanks for hanging out there. It was fun. I haven't done this experiment before where I tested a bunch of waters. I think this one went pretty well. Hello there, Ramon. Great to have you on board. Thank you there, Dimitros. Appreciate that. Thank you there, Dimitros. Welcome aboard. Hello there, Varksy. No, they're not, Roger. They couldn't sell them if they were. What are the most common foods that are highly basic? What do those taste like? So bases, like, they impart bitterness to our flavors. So chocolate has some base in it. Coffee and tea can have some base in it, and that imparts a more bitter flavor. Acids, when things get on the acidic end, they tend to taste more sour. So your citrus fruits, your vinegar, your soda pops with a little bit of, they put phosphoric acid in Coca-Cola, for example. That imparts a nice, we humans, we like that acidic flavor. We put oil and vinegar, right? And that bitter stuff, that's got that more fishy. So the fish flavor, the fishiness, that comes from basic compounds. And we tend not to like the fishy flavor. So what we do is we neutralize the fishy flavor, the bases that are on the fish. How do we do it? We know how we do it. We add a little squirt of lemon. And you're just adding the citric acid from the lemon. That's going to neutralize the fish. The amines are what they are. Those are the bases on the fish. And that's going to neutralize those molecules. And so they don't taste the same. They don't taste as sort of that fishy bitterness. The other thing that goes on there is that the fishy molecules, they're aromatic. They escape into the atmosphere easier. So when you take a bite of that, it gets into your nasal cavity and you're able to sort of experience more of the flavor when things get into your nasal cavity. When you add that squirt of lemon, it makes them not so volatile and they don't get into the nasal cavity as well. And so that attenuates that fishy flavor. So there's a lot of chemistry going on with the addition of just a little bit of a lemon to your fish. There are, Charlie, I need a periodic table shower curtain. What water is typically safe and healthy? Ross, just about any you can get. You know, they're not going to be, okay. Look, I know there's been times in history right here in the United States when, municipalities have had their water systems fail. Flint, Michigan is a perfect example of this, where the local municipality failed in terms of the water that they were providing to the public. However, they found out about it, of course, kind of late, but nevertheless they did. And when they found out the problem, they worked to fix it because, if you're providing water to the public, you're going to have a bunch of chemists and scientists making sure that stuff is safe. So just, be vigilant about checking your water. Look online at your local, your water sample stuff. That it should be online for your local municipality. If it's not, don't drink it, okay? If it is, just read through it. If you have any questions, call the local water company. If that bothers you and that makes you nervous, then certainly you can buy, just about any water on the market, any bottled water on the market. And it just depends. What do you want? What taste do you like? You're not going to be selling bottled water if, it's not going to be safe. Now, there is a concern about microplastics. There is. And I will tell you, from what I've been able to read, that water that has been purified through reverse osmosis, it does a really good job of removing the microplastics. It doesn't mean you get rid of them all, but you're going to have more of them actually removed than in most cases even well water. So, and this is just one study that I read, folks. So, I haven't comprehensively studied this. So, I certainly welcome pushback because I am not an expert on water. As you know, there's a lot to know. Hey, thanks, Sarah Fleur. Appreciate it. Thanks, Fleur, for the subscription. Appreciate that, Llama. Oh, some physical chemistry. I'm a physical chemist, Zaheen. Thank you there, Charlie. Sorry, I'm skipping through some of these comments because I'm behind. What's a bottled water that's reverse osmosis? Aquafina. Distilled water's pretty good too, man. Can you help me with ionization of drugs in the body? Probably not, Future Farm. That's a little bit too much pharmacy for me. This should give me a specific question. If you give me an actual specific question, I can help. But I'm not going to be able to give you an introduction to something like that. Hey, thanks, sir, Addie. Appreciate that. Glad you like my shirt. Yeah, we had a good time today. We had a good time. Tune in, Tommy. Welcome aboard. Welcome aboard. Hello there, Zaheen. What bottled water do I drink? Ross, what I do is I filter my water from the tap. But, if I'm going to go to, I just went to I was thirsty. It's hot here. It's the summer right now. And I just finished playing some pickleball. I like playing pickleball. I was hot. I played for hours. I went by the gas station, and, I don't know, Evian looked good to me. So I drank some Evian water. It was very tasty. Favorite beer? So Future Farm. So I can't drink. Let me tell you why. So it just affects me like crazy. So I'm a huge University of Michigan football fan. I got my PhD at the University of Michigan. So you might know that University of Michigan and Ohio State University, you might know that they're rivals, like big time rivals. And so every year I love watching the Michigan, Ohio State football game. So I was over at my buddy's house watching it, and he gave me a wine cooler. And I drank half the wine cooler. And listen, I'm watching the Michigan-Ohio State football game, and I fell asleep. So think about that. Just think of how much alcohol affects me. If I had half a wine cooler, I'm pumped up watching the game, and I still fall asleep right in the middle of the game. So, I avoid alcohol. So I'm 57, Peter. Go blue, baby. Go blue. Ann Arbor, you got it, Future Farm. It is there, True Tommy. Hey, thanks, Sarah, PSS. Appreciate that. Appreciate that. Sorry, Charlie. But, hey, a lot of Germans like football. European football. So it's the same kind of thing. Think of your two favorite European football teams and, imagine them playing and, you fall asleep during the game. That's the analogy. All right, folks, I'm going to get out of here. I've gone a full hour. That's how long I usually do. I usually do this on the, Audie, I don't know. I don't know what my next experiment's going to be. I'm thinking about doing some stuff with light sticks next. So I have some light sticks that I might be playing around with. I do some stuff with this weird bottle here, this kind of bottle that, it does some interesting things. I've done some experiments with this. I do all sorts of crazy stuff down here. All right, JJK. Thanks, Air Desert. Thanks, Obtours. JJ, let me hear your question. So, Obtours, I try to do this about this time, either Saturday or Sunday. So this week, last 2 weeks I did Sunday, some with Cheetos. I think that's some with Cheetos. Hey, do me a favor, check out my newest short. You're gonna love it. I'm telling you. If you like Breaking Bad, I did some experiments and I kind of leaned into the Breaking Bad thing. So if you like that, you check that out. My newest short I just put out this Saturday, this morning. If you would want to know every chemical reaction, would you have to memorize it, or would it be like adding numbers? JJK. So I think you don't need to memorize chemical reactions. What you can do is learn to identify different types of chemical reactions. And when you learn to identify the different types, you can often predict what's going to happen. In general chemistry, we teach about 4 or 5 general types of reactions that are kind of easy to identify. Those are acid-base reactions. Those are precipitation reactions, where a solid forms from 2 fluids that you mix together. That's going to be a precipitation reaction. There are gas-forming reactions, which are exactly what they sound like. And then there are going to be oxidation-reduction reactions, which involve, metals being oxidized and forming compounds, or you can have compounds being reduced and forming metals. And there's a lot of variations on that, but those 4 are your main ones. Hello there, Jaden. Hello there, Ivana. Hey, thanks there, Desert. Make sure you say hi in the comments so I can see you around. All right, folks, I'm going to call it off for the day. Great hanging out with you. It was a lot of fun. Thanks for hanging out. Consider subscribing. Tommy Technetium. Yeah, check out my shorts videos. We had a lot of good time on this channel doing a lot of science. You like science, you like nerd. I'm a nerd, baby. You like that kind of stuff. You like someone leaning into the nerd, the beautifulness of science, the fun of it, the gloriousness of it, the beauty of it, and just the plain fun of it, and, some of the cool, interesting facts of it. Yeah, you might like the kind of stuff that I do. So thanks for hanging out. I'm going to see you next week. Thanks, Audie, for the subscription. Thanks, Future, for the sub. We're going to see you guys later. So long.